I'm showing you how to do kinetics, fluorescence kinetics, using the Lumina fluorometer. So instead of wave scan, I'm using time scan. So it's communicating with the machine. If you can hear the sound, that's the communication with the machine, testing things out. Start with new. So I'm giving this a title. I'm doing a proteolysis of a peptide, so 40 microliters of my red peptide, 4 microliters of trypsin. So this will save the data. I get a blank screen, and here in the corner are where I need to make some important inputs for what the parameters are for this experiment. I am doing EDANS fluorescence. First I'll set this to 350. We did a standard curve with the PMT, the photomultiplier tube, at 350 volts, so we'll keep it at that same level. Integration time 100 milliseconds. That gives you more time to collect photons. It gives smoother data than the default 20 milliseconds. Need to set the excitation to 340 for EDANS. Emission is 490 nanometers. Now this one is new here, the time setup. Looks like the default is to take a sample every 100 milliseconds. That's far too frequent for me. So let's make this 10 seconds. It'll take a data point every 10 seconds. And total time, let's go for 30 minutes. That's 1800 seconds. So it'll take 180 data points. These would be useful if we had linear data. In this case, I'm not expecting a line, so I'm going to uncheck those. But they could be useful if you had just linear data. Update. I'm going to check to make sure everything is as I want it to be. This looks great. I'm not changing any of these defaults. These were the same settings for the standard curves, so I'm not going to change them. So now I'll add my trypsin and start the fluorescence data collection. Actually going to start the data collection here so I can get the initial fluorescence before adding enzyme, and then I'll hope that I'm fast enough to get the trypsin in there and not make my graph too ugly. So here it's taken 1, 2, 3 data points already, and that gives me the initial sort of fluorescence before I add the enzyme. Now I'll add the enzyme. Here you can see my cuvette. It's got color because the EDANS here is quenched with Dabcyl. Trypsin in, 4 microliters. Parafilm to seal the tube, 1, 2, 3. Back into the machine, close the lid. So now I'm expecting to see the fluorescence start rising rapidly. As the peptide gets cut into 2 pieces, we're separating the EDANS fluorophore from the Dabcyl quencher. So this is a great way to measure the rate of proteolysis, the rate of trypsin cleaving this peptide. And there we are, off to the races. So we'll come back in a few minutes and see how things look. So now more than 20 minutes have gone by, and you can see a nice increase due to the trypsin digestion, and we're leveling off at a little above 3,000 photon counts. Once the run is complete, then the data shows up on this beautiful graph here. I will save this data. So I will go File, Export Chart as a picture. I'll use JPEG. And I will call this cell proteolysis. This is 40 microliters of red peptide plus 4 microliters of trypsin. So that saved the data as a picture, just this graph, so I can paste that graph into my notebook, for example. I'll save the actual data so that I can compare to other runs that I've done. So here it says data, Excel, save. Okay, so let's call it the same thing. Alright, so now that saves all the data points. And then I can put these into the Dropbox and have access to them from anywhere in the world, really.